All right, moving into our next unit, we're going to be looking at shapes, at 3D shapes. And so our first part is surface area, which is what it sounds like. We're finding the area of the surfaces of these 3D shapes. Okay, but to begin with, we've got to look at our 2D shapes. Okay, we've got to, let me get back in here. We've got to make sure we can find the area of all the different parts. So we got to review 2D shapes. All right, so a triangle, to find the area of your triangle, hopefully we remember this. It's 1/2 base times height. All right, a rectangle or a parallelogram is length times width or base times height. Same thing, just depends on how you look at it. Okay, your rhombus and kite. Now, your rhombus is a parallelogram. We talked about that with our quadrilateral. So you could use base times height if you're given the base times height. But we also have a formula for a rhombus and a kite, and it's P times Q divided by 2, where P and Q are your diagonals, right? And our diagonals go from opposite vertices, right? Cut across. So if I sketch a kite over here, okay, you got a diagonal there and a diagonal there. So we can call those P and Q. So to find the area, if you're given diagonals, is P times Q divided by 2. Right? You need to make sure you know how to find the area of a trapezoid. Okay, so to find the area of the trapezoid, we take the average of the bases times the height. Remember, your trapezoid, you have 2 bases that are parallel. Right? So average of the bases means I add together and divide by how many I have, which is 2. Right, times the height of my trapezoid. So add your bases, divide by 2, multiply by the height. And then our circle, we've seen a lot. Area is pi r squared. Okay, so you got to make sure you're familiar with the 2D area formulas. All right, moving into, wrong way. All right, moving into our 3D shapes. We got to first talk about the 3D shapes we're going to be working with. Okay, so our prism. Our prism is our box, right? The one that you're most familiar with, okay? But a couple of things about your prism. A prism is characterized by 2 congruent bases connected by rectangles, all right? So that means that if I were to draw a trapezoidal prism, all right, I'm gonna have a trapezoid, okay? And then it kind of extends back to give us the 3D part. And it'll look like this, all right? Sometimes you'll see your dotted lines, right? And dotted lines just means that it's something that you wouldn't see if it were solid. That's like if it was a see-through trapezoid, you can kind of see the other edges in there, but if it were solid, you wouldn't be able to see it. So that's all dotted lines mean. All right, and you name a prism based on what the base is, what shape the base is. So this one we would call a trapezoidal prism because the base is a trapezoid. Okay, when picking the base, you've got to pick the non-rectangular shape. So even though it looks like that would be the base because that's what it's sitting on, that's not our base. Your base has to be the non-rectangular shape. So my trapezoid is going to be my base. Okay, your base also has another base that's congruent and parallel. They're like would never touch if they kept going. So that one in the back has to be my other base. Okay, if you have like a box and it's all rectangles, it doesn't matter which one you pick as your base. But if there's a non-rectangular shape, that's got to be the base for your prism. Okay, a cylinder kind of goes with a prism. A cylinder is like a circular prism. So there's not going to be any rectangles, but I do have 2 bases, 2 congruent and parallel bases. Oops, dotted lines are struggling. But my bases are circles. Always. So there's a base and then there's my base. All right. Our pyramid, okay, just like in Egypt, your Egyptian pyramids. Oops. We'll do a square pyramid. All right, your pyramid is going to have one base and it's going to come to a point kind of opposite that base. So in this case, my base is a square. So just like with your prisms, you name it based on the base. So this would be a square pyramid. And a pyramid is characterized by one base and then triangles coming from each side of that base that form at your one vertex at the top. All right, so this one's going to have triangles all the way around. So a prism has rectangles, a pyramid has triangles, right? And just like before, your cone is pretty much a circular pyramid, right? So you have a circle base, and then it's going to come to a point, like your ice cream cone. All right. And then our sphere is a ball. We all know what a sphere is. All right, now they usually, to make it 3D, they'll give you this curve out front and then your dotted line in the back, because you wouldn't actually see that if it were solid. All right, but that specific circle that they give you in the middle is what we can call the great circle. Okay, your great circle means that the radius of that circle is the same as the radius of the sphere itself. Okay, so that's important because sometimes they ask you or give you a problem where they talk about the great circle. And if they give you the radius of the great circle, then you know the radius of the sphere because they're the same. Okay, and then one other shape I didn't add on here, but it might pop up, is a hemisphere, which is half of a sphere, right? Which is just like Patrick's house, his rock, and SpongeBob, right? Just cut your ball in half and there's your hemisphere. All right, so we don't really have a lot of formulas. There are formulas, but we're not going to worry about them for the most part. We have a few we're going to look at, but finding surface area means we're just finding the skin of our shape. So we're looking at just the outside part, nothing on the inside. So one option is to use what we call a net. All right, so our net is if you unfold your shape. All right, so for example, if I were to unfold a box, right? So I start with this box. Well, you know what? Let's do the trapezoid. So if I were to unfold that trapezoidal prism that I drew a minute ago, ooh, that's a rough one. All right, I'm just going to flatten it out. Okay, so if I start with my base here, all right, there's my trapezoidal base. Okay, then let me switch colors. You know, you got that base that's on the bottom, or not the base, but the side that's on the bottom. So I'm going to draw that one here. All right. Then you got this blue side and then another blue side over here that actually is the same, right? Both of those. So I'm going to have those rectangles on both sides. Right. Then we got, let's see, we'll do the top, which is another rectangle. So I'm just going to add that around here. And then we got that back trapezoid, right? Your back base back there. And that one can touch here. This is not the only net that you can have. This is just a possible net, right? If I kind of pick up my two bases and then fold these around, you end up with that same shape. So that is your net, right? And then if you're given dimensions, all you have to do is find the area. So I have to find the area of the trapezoid, then the bottom one, and then you got these four rectangles, which are pretty easy to find the area for. So that's using a net. A net is especially helpful when you're finding the surface area of a cylinder, okay? Because a cylinder is not as easy to do option 2 with. Okay, now a cylinder also has a weird, I don't know where to write it, we'll write it over here. A cylinder has a weird shape. So if I take a cylinder, right, and I unfold it, I'm gonna have a circle. I have a circle for my base and a circle for the bottom, right? But then if I unfold like the middle part, it actually unfolds into a rectangle. Right? Just like when you, like you have a poster board and you're taking it to school, so you roll it up so that you can, carry it easily, right? You make that cylinder shape, that cylindrical poster board, right? So your cylinder, when you unfold it, you actually end up with two circles with a rectangle in the middle. This is much easier to find the area of than if you try to look at it on here, like just a 3D shape. But there is a trick. All right, finding the area of the circles are easy, right? Those are pi r squared. Easy peasy. All right, and then I'm going to be given the height. This is going to be the height of the cylinder itself. But this width here, right? That's not going to be a set width because when I roll it back together, it's a curve. It's not just like a line, right? And it specifically is my distance around the circle, right? Because it's going to fold back up and go around the circle. Well, my distance around the circle is circumference. Okay, so that means the width of every cylinder, the rectangular part, when I look at the net, is going to be the circumference, which is 2 pi r, right? So to figure out this piece, we end up doing our length times width, or our base times height. So we get 2 pi r h. And that's always going to be the case, so I would have this written down. It is technically a formula. We're not going to worry about having to memorize a formula as long as you understand the concept of what your cylinder looks like when you unfold it. All right, and then our other option is, come over here, a different color. Option 2 is to add the different faces, which is basically the exact same thing we just did here with our net, but without writing it down. And again, this is the one I use most, except for a cylinder. A cylinder, we got to use our net to be able to visualize it. All right, so for example, if I gave you that square pyramid, all right, so all my sides are going to be the same for my base. So we'll say that they're all 5, because 5 is pretty easy to multiply. And then I'm going to give you what we call a slant height. So it's not the height of the pyramid because it doesn't go straight down to the base from the middle, but it is the height of the triangle that's on the side. And I'm going to make that height 10. 10 is pretty easy to multiply too. All right, so I need to find the area of all these different pieces. Now, because this is a square pyramid, the four triangles, not rectangles, the 4 triangles are all the same. Okay, so I can cut myself some work there. But if it was a rectangle, you would have different sized triangles. So pay attention to what it looks like. All right, but I know that I have the bottom. So if I start with my base here, that's a square. So it's going to be 5 times 5. All right, then I'm going to have 4 of these triangles. So I'm going to have 4 times the area of these triangles, which is going to be 1/2 base times height. Well, my base is 5. My height is 10. 5 times 5 is 25. Right? 5 times 5, or 5 times 10 is 50. Divided by 2 is 25. So then we get 25 plus 100, or 125. And we're working with area, so it's 125 square units. Okay, so this is really the same thing as drawing your net. It's just without actually writing it out. Okay, so you don't have to do a net every time unless you want it to, see it. Some people are more visual, so maybe you want to be able to see all your different shapes drawn out. Okay, but for a cylinder, it's important. You want to be able to see that shape. All right, we do have some formulas, okay, like the cone, the sphere, and the hemisphere. So the cone, if you imagine taking a cone, oh man, it's a rough looking cone, and unfolding it and making your net, you end up with that circular base and then this weird curve, like a piece of the pie. All right, so this one, this isn't a shape. This isn't one of our 2D shapes that we have an area for. So I can't just find the area of this piece of the pie unless I was given, the angle there, doing your sector area, all that stuff that we've already done. But we don't usually give that to you. All right, so the cone we do have a formula for. So surface area for a cone is pi RL plus pi r squared. Okay, and that L, that weird looking L there, is our slant height. So it's not the height of your cone, it's the slant height. So your L is like this one. I'm drawing that one. It is like this piece right here, the slanted height. We do a cursive L for that because it's not H. H is the height of the whole pyramid. All right, so for example, if we hop down at the bottom, if I give you a cone, nice and crooked, and I tell you that the radius is 2, and we'll say that nope, we won't do 2. Let's do it. We'll say it's 5. All right, and then the height of this whole thing, my pyramid, we'll say is 12, and I want to find the surface area. So I did this on purpose, just kind of throw a few things in at one time. All right, if I want to start plugging it in, I would say that my surface area is pi times my radius times my slant height. But I'm not given the slant height. I'm given the height of the whole cone. That's my 12, right? But I need this height over here, my slant height, right? Well, I did this on purpose because sometimes they ask you questions like this. If you're not given the slant height, you're going to be given enough information to find the slant height. So like right here, I have a right triangle. So if I redraw that right triangle out here, right, I'm given the legs, I'm given A and B, and I want to look for C, right, Pythagorean theorem. So we can say 5 squared plus 12 squared equals C squared, then we can solve and figure out L. I also made some numbers where it's a Pythagorean triple, right? So that means that it's 5, 12, 13, okay, which you would have gotten had you simplified your Pythagorean theorem. All right, so that means I have pi times my radius times my slant height, right, plus pi times my radius squared, okay? This is actually what we call lateral area, right, which is just the sides without the base. So then we had to add in our base, pi r squared. Not a big deal. Just make sure you know this formula and you have it written down. All right, so 13 times 5 is 65 pi. 5 squared is 25, so we get 25 pi. And we add those together, we get 90 pi. Okay, if you look at your multiple choice answers when you answer these, but if it says to leave it in terms of pi, that means you leave pi in your answer. You don't actually plug it in. But it depends on the problem. It depends on what the question's asking for. So it might want you to plug it in, right? So if I were to plug in 90 times pi, we get about, we're rounding, 282.7. That's very sloppy, my apologies. Okay, so pay attention to what it's asking for. If it wants it in terms of pi, don't plug in pi into the calculator. If it doesn't, go ahead and plug everything in and get your decimal. All right, back to our formulas. So for a sphere, the formula that you just got to memorize, kind of random, comes out of nowhere. It's 4 pi r squared. All right, so a sphere, the surface area of a sphere, is 4 times the area of that great circle. Okay, so 4 pi r squared. And then a hemisphere, you would think, would be half of that sphere. But if I take my sphere, right, which is all nice and rounded, ooh, get there, and then I cut it in half to get my hemisphere. A hemisphere adds a base that the sphere does not have, because the sphere doesn't have any bases because it's rounded. So I can cut my hemisphere, or cut my sphere formula in half. So 4 divided by 2 is 2. But then I have to take into account that bottom circle. So to find the area of that circle, we have pi r squared. And then if I have 2 pi r squareds plus 1 pi r squared, I'm left with 3 pi r squared. So again, you don't necessarily, this is just where it comes from, but you just got to make sure you have your formula written down or memorized. All right, so then for example, if I give you a hemisphere, all right, and we'll switch it up. I'm going to tell you that this is 4. All right, well, because it's going all the way through, you have to assume that that's your diameter. If it was going to give you the radius, it wouldn't extend it. It would come just from the center out. So we're going to say that my diameter is 4. So if my diameter is 4, that means that my radius is 2, and I work with the radius. That's what we need. So the surface area of my sphere is going to be 4 times pi times 2 squared. Well, 2 squared is 4, and then 4 times 4 is 16. So again, in terms of pi, is if I just leave it as 16 pi. Or depending on the question, it might want you to plug it in. And if we do that, we get about 50.2. So it just depends on what the question's asking for. Some of them are in terms of pi, some of them are as decimals when you plug everything in. All right, so that's it for our surface area. So if it's not circular, you can just add up all the different pieces. Okay, if it's circular, which means it's a cylinder, you got to kind of unfold it, think about what it looks like, and add them together. And then our cone and sphere and hemisphere have a specific formula that you can just plug in to figure out the surface area of any of these shapes that we're working with.